Welcome to Spring LIB.
In this question, given data is there is a figure given. So first I will draw this figure and explain the data given. So you can see that in the figure there is a hard surface given, and on this hard surface there is a bigger block is lying. So figure of this bigger block is that is like this, and in the question it is saying that the mass of this bigger block is capital M, and further information is that is this half surface, this surface is in this part, this surface is given, that is shape of this surface is that is semicircular. Now further information is that is in this figure there is a point considered at this middle point of semicircular named as that is A, and there is a small block given whose location is initially at here. Consider that initially in the question it is saying that initially it is at rest position, and mass of this smaller block is given, that is small m. Now in the question it is saying that this small block is moving with a speed that is given v in this direction and reaching at a point. So the question is asking that after reaching at point A we have to find the speed of bigger block. So this is the question. Now let's start answering this question. So in the answer, the mass of smaller block is given, that is small m, and I can say that the initial speed of small block will be, that is in the question you can see that in the figure there is a v given, so I can say that small speed of small block will be, that is v, and small v, that means, and the mass of bigger block is given, that is equal to capital M, and I can say that initial speed of bigger block will be, that is 0, because you can see that the bigger block is at rest position, so I can say that it have no velocity or no speed, so that means equal to 0. Now next step is, in the question it is saying that this block is moving with smaller block will, that is small block is moving with speed, that is v, in this direction and reaching at point A. So what happening is, after reaching at point A, a small block will transfer its momentum to bigger block, and both will move, both block will be with same velocity, will move with same velocity. Consider that velocity is, that is capital V, and direction will be, that is in the same direction in which the small block is reaching at point A, or I can say that in the same direction as small v have. So now next step is, that is here I am applying the law of conservation of linear momentum. So I can say that according to this law, initial linear momentum will be equal to final momentum. So here on the left side I will write the initial momentum, that will be written as, that is small m times of small v plus capital M times of 0 is equal to. Now on the right side I will write the final momentum, that will be written as, that is small m plus capital M parenthesis of small m plus capital M multiplied by capital V. So now simplify it, then I will get the answer for capital V, that is equal to small m times of small v divided by small m plus capital M. So this is the answer of given question, that is speed of bigger block will be when the smaller block reaches at point A will be, that is V, that is equal to mv small m, that is capital V is equal to small m multiplied by small v over small m plus capital M. So I had solved the question completely. Thank you.